A very warm welcome everyone. A very interesting research has been published by Indian scientists which claims that triple dip LaNina conditions actually ended up improving the air quality of North India, while on the other hand it ended up deteriorating the air quality of peninsular India. Let's understand all the technicalities that need to be understood in this concept. First of all, what do we mean by El Nino? What do we mean by La Nina? We look for the deviation of temperature of the ocean water in this part of the world. If the temperature in this part of the world is more than normal, we call that as a warm phase or El Nino. If the temperature of this part of the Pacific is below normal, we call that as a cool phase or a La Nina. What do we mean by a triple dip La Nina? As you can all see, a positive deviation of temperature more than normal temperature forms a crest, that is El Nino. Below than normal temperature is represented by a trough, which is also called as a dip. So triple dip La Nina simply means that for 3 consecutive years La Nina conditions were observed. Which years to be precise? 2020, 21 and 2022. Right till December 2022, the world observed a La Nina condition. It was the 3rd consecutive year when we observed below than normal temperatures of ocean waters in this part of the Pacific. Let's understand how does it end up affecting the air quality on India. First, when we talk about La Nina conditions, we see an upwelling of cold water in this region, which ends up creating a high pressure in this area. All this high pressure actually ends up intensifying the trade winds. We have more than normal, very strong easterlies developed during a La Nina, which is why all the warm water ends up pooling in this part of the Pacific. Accumulation of warm water leads to the observance of very strong convection, leading to the formation of a low pressure condition. The stronger the La Nina, the greater will be the latitudinal impact of the low pressure. When we talk about the monsoons, we are referring to this patch of the South Indian Ocean. Why do we talk about this particular patch? The high pressure belt is found in patches, and the patch of the high pressure belt found in the southern part of the Indian Ocean is called the Mascarene High. Why is it called the Mascarene High? Because over here we have 3 islands. We have Reunion, Mauritius and Rodrigues. Collectively, these 3 islands are called the Mascarene Islands. Therefore, this patch of the high pressure belt is called the Mascarene High. Why is the Mascarene High important for the Indian monsoons? Because it is the source of the wind system which actually brings the monsoonal rainfall to India. During summers, the ITCZ shifts northwards, extending the domain of the Hadley cell of the southern hemisphere. The southeast trade winds cross the equator. Because of Coriolis, they start deflecting to the right and enter India as southwesterlies. Stronger the Mascarene High, more powerful will be these southeast trade winds. More powerful will be the monsoonal wind system. What is the impact of La Nina on the Indian monsoons? As we are all aware, stronger the La Nina, greater will be the latitudinal effect of the pressure that it creates. That is called the coupling effect. When a low pressure is created in this particular area, as we are all aware, low pressure is a convergent wind system. A convergent wind system is present on the surface because of La Nina. Convergence leads to convection in the upper atmosphere at the tropopause above the southwestern part of the Pacific. We find upper air divergence. Upper air divergence because of very strong convergence on the surface. Upper air divergence forces air to move towards the mascarene high. In order to strengthen the high pressure at the mascarene high, we need a very strong convergent wind system over the mascarene high at the tropopause. This low pressure, because of the LaNina condition, actually strengthens this convergent wind system over the mascarene high, forcing more air to sink over this part of the high pressure belt. Actually, it ends up strengthening the mascarene high, ending up increasing the velocity of the wind system, which actually pushes the air mass over India to cause rainfall. So basically, stronger the LaNina condition, stronger will be the mascarene high, stronger will be the wind circulation, which actually brings monsoonal rainfall towards India. It is basically in the formation of the Hadley cell itself, surface winds, convection along the ITCZ, upper air divergence, all the upper air circulation crosses the equator, deflects to the left because of Coriolis, again ends up sinking on the high pressure belt. This is the monsoonal cell created by the strong mascarene high. How does it affect India's air quality? The main monsoon for India is the summer monsoon, that is the southwest monsoons. Stronger LaNina favors stronger southwest summer monsoons, but the domain of southwest monsoons is limited to three parts of India. Either it is the west coast, the northeast, and the entire foothill area, the entire northern part of India. A better circulation because of a stronger mascarene high results in removal of all the pollutants from North India. Peninsular India is more or less devoid of rainfall because of the southwest monsoons. LaNina therefore aggravates the circulation of wind system of the summer monsoons, allowing more air to recirculate over North India. These conditions persisted for 3 consecutive years, which is why for 3 consecutive years, better circulation of air during the monsoons was observed over North India. What about the peninsular India? We can clearly establish a fact that yes, indeed, triple dip LaNina conditions ended up improving the air quality over North India. But what about the impact on peninsular India? Let's understand that. When we talk about the impact of the LaNina condition on peninsular India, we need to understand the concept of winter monsoons. That is the northeast monsoons observed in winters, which bring rainfall to the Coromandel coast. What brings this rainfall? Because by winters, the subtropical high pressure belt re-establishes itself over this place. Winds originate from a high pressure and they move towards a low pressure. Winds initiate from a high pressure and move towards a low pressure. During winters, the ITCZ is still present over the Indian peninsula, which is why this is the ideal direction of the winter monsoons. What is the ITCZ? It is the belt of low pressure. Winds will be attracted towards a low pressure. Due to 3 consecutive years of LaNina, a stronger low pressure was present, but it was not present in the right direction. This strong low pressure, because of LaNina, it ended up diverting winds away from the Indian subcontinent. Therefore, for 3 consecutive years, peninsular part of India has not received adequate rainfall due to LaNina in winters. Poor northeast monsoons have been associated with LaNina conditions. Therefore, in summers, no circulation of air over peninsular India because of southwest monsoons. Whatever rainfall was received during the winter monsoons was obstructed because of LaNina. Therefore, no rainfall, no circulation for the past 3 years over peninsular India has led to deterioration of air quality in this area. A fact needs to be considered. A reference has been made to Mumbai in this entire research. It has been mentioned that the air quality in Mumbai has actually deteriorated. Now, going by the logic that we have just understood, technically it should have received better rainfall because it receives rainfall during the summer, you can say southwest monsoons. They were strengthened because of triple dip LaNina. But why did Mumbai receive lesser rainfall? Because something happened last year. Bigger and you can say larger extent temperate cyclones were observed, which actually provided a lot of cloud cover and a lot of rainfall. They did not allow the surface of North India to cool down. Since the surface of India did not cool down even till June, the easterly jet stream was not able to form. If the easterly jet stream is not able to form, there is no vertical wind shear. Tropical cyclones can originate. Why? Because we had a very strong positive Indian Ocean dipole present last year as well. All of this moisture which should have added rainfall to India was ended up creating a tropical cyclone called Biparjoy. Biparjoy actually depleted a lot of moisture from this air mass, which actually ended up deflecting the winds away from India as well. But ultimately it was pushed towards India because of the nearby subtropical jet stream. Nevertheless, the impact of the formation of Biparjoy was only because of the late formation of the subtropical easterly jet stream. That ended up removing water and moisture from this air mass away from Mumbai, forcing Mumbai to receive lesser rainfall even during the summer monsoons. Piling up of all the pollutants did not allow the air quality to improve. So that is all with respect to this research. Since we are already on this topic, I would just like to add one thing. When we talk about the present situation, a very strong El Nino was indeed present, but now it has started to weaken. Chances are that by June, by the time we try to expect the summer monsoons over India, the impact of El Nino would have reduced. It would have reduced considerably, meaning thereby the impact of El Nino this year on the monsoons is going to be less. But a LaNina will not have developed completely. So again, it remains to be seen whether peninsular India will receive good rainfall or not. So that is all for this concept. Stay tuned for more information. Thank you so much.